Jonathan, what brings you to the conference today?
So I've been working on a project for the last 6 years. It's basically a sustainability project. And it's about how can we make a sustainable version of liquid fuel? How can we increase our available freshwater supplies? How can we make local food supplies? And how can we do all of this without damaging the environment? And I've been working on a solution to that problem, at least for coastal cities, for these last 6 years.
And what does that solution look like so far?
So the solution we call OMEGA. It stands for Offshore Membrane Enclosures for Growing Algae. It turns out microalgae are an incredibly good source of liquid fuel. Algae make lots of oil. In fact, 90% of the fossil oil we currently get from the deep earth or under the ocean comes from microalgae. And these microalgae not only make oil, usable oil, but they can grow on wastewater. So we can grow them on sewage from our cities. So we can grow the algae on wastewater, and they're freshwater algae growing in these containers as we envision the OMEGA system floating offshore. So we're not using land, we're not using water, we're not using fertilizers, we're not competing with agriculture to make a biofuel.
If they grow on wastewater, does that mean that they're consuming the waste? So
Yeah,
the waste goes away?
They're removing stuff from the wastewater that is otherwise just being thrown out into the ocean that causes algae blooms in the ocean, which are problematic. So these algae blooms are actually controlled algae blooms, and we use the algae that are being produced for positive things, in this case for making fuel.
And can algae be turned into fuel on the scale required by our industrial society?
Oh, this is a very good point. City of San Francisco, for example, is producing 65 million gallons per day of wastewater. Between San Diego and San Francisco, it's about 1.2 billion gallons of wastewater per day that's dumped off into the ocean already. So the scale is significant. But in terms of the production that we now use, because we're using so much energy, San Francisco, we can produce about 20% of the diesel required for the city of San Francisco. But the good news is we can also, by economizing, save maybe 60 or 70% of what we're currently using. So we can get close using algae.
So algae basically turns into something like oil that can burn?
Exactly. You can make the algae, you can process this algae biomass into a fuel, and the algae not only took wastewater and grew on the nutrients in the wastewater, but they took carbon from the atmosphere to grow because they're doing photosynthesis. So they use carbon dioxide. That's a greenhouse gas. So they capture carbon, they clean the wastewater, and they're freshwater algae living in a marine environment. So if they escape into the environment, they die. So they can't damage the environment.
Now, how do you hope that attending this conference will move your project forward?
So the franchise for humanity is a brilliant concept, really. I mean, the notion that I'm looking at is how to move this technology forward into the world as rapidly as possible. So I just spent $10.8 million from NASA and from the California Energy Commission to do a feasibility study here in the United States, mostly in San Francisco.
So people are taking it seriously enough that they're willing to invest $10 million in it.
And we've done now the basic feasibility. The issue now is, can we build a system somewhere in the world, anywhere in the world, where we could put it offshore in a protected bay and people can walk out on the floating infrastructure. And this floating infrastructure, by the way, is envisioned to have solar panels on it. So we not only will be generating energy for liquid fuels from the algae and the wastewater and the carbon from the CO2 source, but we'll also have solar panels floating offshore in this infrastructure with water-cooled batteries and so on. Wave energy is possible and wind energy.
What is the biggest thing impeding the project right now? What's preventing it from moving forward more quickly?
I think it's really now a question of finding people in the right locations around the world to take on the project. We're trying to do it as an open source. So it's not a business. It's not meant to be a business because it's something that has to be taken up by people around the world who will either need water or need fuel or need local food production. So we're looking at places like Africa, South America, Middle East, anywhere. Island nations are really excited about it. So We're just going to present it as this sort of open source technology with the idea that the currency is not going to be money, where it's going to be information. So and we're going to give you the technology. In exchange, we're going to get back information from you about how effectively you could develop and implement it.
It sounds like the overhead costs for starting up would not be that great compared to, say, drilling for oil, because
no.
algae is cheap and sludge is cheap.
Yeah. In fact, it doesn't turn out to be very expensive at all. We're building, imagine these sort of plastic tubes made of flexible, inexpensive plastic. We use a polyethylene plastic that's used for making greenhouses. It's called linear low density polyethylene. Very inexpensive plastic. The world already makes 40 million tons a year, so it's a huge amount of plastic already in the world, and it can be recycled. So these plastic tubes floating offshore are water cooled, and they're fresh water, so I mentioned, so if the algae escape, they're not going to contaminate the environment. And the good news is that there are lots of bays around where we could do this already. And as the sea level rises, which unfortunately it looks as though it's going to rise, there will be new opportunities arising from inundated coastal areas where we'll now be ready to do floating developments.
I understand that you spoke at this conference today. What was the theme of your speech?
Oh, I am hoping that I'll make connections here with people who can reach out into the world and help to develop this technology. I mean, I'm a scientist, and I've been thinking about how to technically solve the problem. There are a lot of social hurdles that need to be overcome. How do you get people to take on this new challenge? People are not behaving as though they really see the crisis that is coming. The purpose of my presentation was to remind people that the world's population is 7.1 billion people right now, and it's projected to get to 9 billion people in the next generation's lifetime. I mean, so we have a train wreck that's sort of happening, and we can see it, but we're not feeling the sense of urgency, and that's what I was hoping to convey to people this morning when I spoke to them.
Do you feel that most of the people at this conference have that sense of urgency, that they are motivated, not just in the energy field, but in other fields in general, to grapple with some of these problems?
I hope so. And the early signs, and the conference is still just starting, but the early signs are there some really good people here that are really going to take on the challenges that are necessary. I mean, the problem, there's an old saying that people's attitude about change is that everybody wants everything to stay the same but get better. And this is a real issue, right? We need to take on the reality of change, and this kinds of transition to the sustainable technologies that I'm talking about with Omega could be an example of how to do that.
What kind of technical background do you need to do the work that you do? Do you have some academic preparation to get started in this?
Well, it's really an interesting, Omega is an interesting sort of new approach in that it's an ecology of technologies. It's an integration of lots of different things. So there's aquaculturists who will utilize this offshore infrastructure. There are people doing wastewater treatment. There are people who are monitoring the whole system. There are people doing solar. There's people doing wind energy, and it's all on the same platform.
Mm-hmm. Okay, very good. I think we're done. Thank you very much.
Thank you.
Thank you.